Hello all, my name is Ganesh. In this session, we are going to discuss about overview of artificial intelligence. What is artificial intelligence? What is machine learning? And what is the difference between machine learning and deep learning? Let's begin with the history of AI. So in 1950s, the first time Alan Turing has published a paper, he has speculated about the possibility of creating machines that can think. Okay, and the journey started in 1956. John McCarthy, a computer scientist who has coined this term called artificial intelligence for the first time. Then in 1960, the first robot was introduced in General Motors assembly line. Then 1961, the first chatbot was introduced, and now the evolution has happened, and today we have Siri, Alexa. There are so many chatbots which can do intelligent work for us. Okay, in 1997, IBM's Deep Blue, who has beaten the chess champion, and in 2005 there's a robotic car, the speech recognition, robotics, smart homes, smart toys, so on and so forth, right? There are so many innovations in this domain have been started. And in 2006, when the deep learning was introduced by Google, so the journey has taken take off, and today we see when it has started as a hypothetical situation, but now it is a most important technology in the industry today. Okay, so that's a quick journey, but let's understand what AI means. Okay, so AI is the field of computer science to create the intelligent machines that can recognize human speech, that can detect the object, that can learn like a human learns, that can plan, that can solve, that can decide on something, the way human does. Okay, it is a machine that can mimic the human behavior. Okay, so any system, anything which can mimic the human behavior in terms of the task, in terms of the planning, in terms of a decision making. Okay, and that kind of intelligence we can build onto the computer, onto a machine, and that is what falls under something called artificial intelligence. Okay, there are some of the applications around us. I'm sure you must have experienced or probably heard about this self-driving cars. Okay, this is a great innovation in the industry, in the history of AI, where the machine, the automobile vehicle can run without the driver, where it will be applied a lot of technologies together: natural language processing, image processing, machine learning, deep learning, reinforcement learning together, and we can have something which does much intelligent work like a human. Okay, Siri is another example which understands and responds to the human speech, right? Amazon's recommendation engine. There are so many recommendation engines, Amazon or Netflix, or many retail businesses today. We can see there are a lot of recommendations, which is customized for the users. Okay, that's the intelligent task, which is a customization as per the customer, and that is win-win for the business as well as a customer. Okay, speed and number plate recognition. This is again one of the very important use case, how numbers can be recognized, how it can detect, how it can define if somebody is violating the rules of the traffic, or if something we want to detect and see what whose vehicle is that, and all of this. Okay, so that's another important use case. There's a predictive search engine. There are so many such predictive algorithms available for us today. Okay, before we deep dive into AI, let's have a quick understanding about the basic terms around. For example, data science, artificial intelligence, machine learning, and deep learning. Okay, they are somehow interconnected with each other. Data science is a huge, a bigger term. Okay, so it's a whole new science of data with which we can build an AI system. We can build some predictive modeling. We can build some analytics, and we can have some deep learning algorithms to build a much sophisticated and intelligent machines that falls under artificial intelligence. Okay, so artificial intelligence is a technique that enables machines to mimic human behavior, but of course that happens through experience, and here data gives the experience. Okay, and hence that is falls under a data science, because data we can bring together and we can bring some sense out of data, and with which we can train our machines to think like a human. Okay, and machine learning is a subset of AI. To build any AI, we can use machine learning techniques or statistical modeling to enable machines to improve the experience. Okay, to improve with the experience. So and deep learning is a subset of machine learning. Okay, where we use machines to think like human does, and that is based on the neural networks theory. So it is a multi-layer neural network which can do this kind of a learning, and that is the best way of learning. That's how the human learns. We are simulating the way human brain learns with the help of neurons. So there is a perceptron which does similar kind of a learning in the deep learning. Okay, so this is the brief difference between all these terms. I hope you know what machine learning is, what deep learning is, and now I'm just trying to highlight what AI is. Okay, so let's understand what AI is and how it is different than machine learning. Okay, so let's name the fruit, and it's obvious, it's apple, it's an apple, and we can see, and the moment I show you this apple, and pretty much a human can intelligently say that this is also an apple, a rotten apple, right? Okay, but we might not have seen such apple ever, right? But still we have that intuition to say that this is an apple, right? But if I give this to a machine learning algorithm which is trained using the apples shown on the first picture, so that machine may not be able to identify this as apple, right? Because machine has a predefined rules which has programmed, and machine cannot predict something which is out of the context or out of syllabus, right? So this is where the intuition is required. Okay, I have another picture here, and if I ask you whether you will cross this bridge along with your kids or family, so I'm sure many of you have answered like no. Okay, so honestly we might have never experienced crossing such bridge, but still we have that intuition that okay, this bridge might break if we walk over this. Okay, it seems like nobody have walked on this bridge for long, right, for years. Okay, so that is what the intuition means, right? So that's what the intuition we get. And when I say intuition, there's a formal definition. You will find it on the wiki. So the definition is when we use the relevant information to make an estimate or to make some predictions about a situation. Okay, and that situation we might not have directly experienced ever. Okay, and that is what is called intuition, right? So while using the useful and relevant information, we want to make some kind of a predictions, right? And that is what the intuition, that's what our brain, our experiences, we learn. Okay, for example, if I'm driving, let's say, and now I want to overtake another vehicle, but it's a narrow road, and suppose the another vehicle is coming from the opposite direction, and I already have accelerated to take the overtake the vehicle, right? So in that case we have a correct judgment, correct? So now if I increase a little bit of a speed, I can easily overtake that vehicle. But if I see some other object or the dog or something is coming on the road, so that's where we have to apply our experience, our judgment, whether I should accelerate more or I should brake and take slow and not to overtake. Okay, so in that situation we just think about the situation, we just think about our skills to drive, just think about the distance, how long this vehicle, the dog is coming, how long the opposite vehicle is there. So that's what I mean by relevant information. okay, using useful and relevant information to make such estimates. Okay, and that falls under AI. That is what is called intuition. Okay, in machine learning we don't have that intuition. Okay, machine learning is not intuitive by nature, so it will give answers to the questions it saw in past. So anything out of syllabus is not handled by machine learning, correct? So machine learning is more of IT plus statisticians came together and get some predictive analysis using some statistical modeling. And deep learning or AI is IT plus statisticians plus biologists, I would say, because this is what we are going to see in a while, how the biologist can have a thought process, how we can bring such a biological neural system into machines using something called a perceptron. Okay, machine learning works with the data, and so deep learning as well. There's a huge amount of data getting generated, so we will skip a little bit on the data part and the machine learning part. So this is a supervised machine learning. I hope you have this understanding in the previous sessions. So supervised machine learning, where we train our model with the supervision. We have labeled data and we feed this data to the machine learning model so that the model will train and be ready to predict any new values which you might give to the model. Okay, and yeah, this is another example of supervised machine learning. We have some predefined data sets and we train our model showing those different pictures of the animals, and the model will say whether it is duck or not a duck for any new input which we provide. Okay, because we train that model using input as well as the output, hence the new input which we give, so it will match all those parameters, all those features of this data, and then it predicts based on the historical knowledge it has, or the relationship it has between the dependent variables and independent variables. Okay, in unsupervised machine learning, it is more of a clustering, so we don't provide any labeling, we don't supervise the classification here, and hence this falls under unsupervised machine learning. Algorithms like k-means or agglomerative clustering falls under unsupervised machine learning. Reinforcement machine learning is another type of machine learning which learns with the experience. Okay, there is an environment, there is an agent performs the actions, and environment throws challenges as well as it rewards and penalize about every action agent takes. Okay, and with that, agent becomes smarter and smarter over the time because it memorizes every reward or the penalty what it receives from the environment. The examples could be the natural language processing, especially the chatbots, they become smarter and smarter. The Alexa, the device which becomes smarter and smarter over the time. This is how the agent learns. Okay, there are a few more examples I will run through quickly. Recommendation engines we saw. Okay, this is especially used in the retail industry, in the e-commerce like Amazon, eBay, right? Then the social media, okay, in the social sites we can see how recommendations can be used, recommendation as well as the tagging of your friends. Netflix is another example of recommendation engine, okay, that falls under machine learning. So I hope you had this understanding. So Amazon Alexa, okay, this is a device which works on an intelligent system. Filtering the spam emails, so that's another system which can be built using machine learning. Now let's have a quick understanding about what deep learning is and how it differs. Okay, so far we have understood about machine learning, where we have a labeled data, we provide this data to the machine learning algorithm, and we train the model so that the model is ready to serve you for any new data which comes to you, so that the model will provide a prediction. Okay, deep learning consists of one input and one output with the multiple fully connected hidden layers in between. Now what is this hidden layer? So, and what is this input? What is this circle, right? So each layer is represented as a series of neurons. Okay, and the neuron here is a single layer perceptron. We will be talking soon. So here the deep learning is the algorithm which is used for AI. Okay, so the deep learning algorithm is called artificial neural network. So it works on a neural network which is artificially created, okay, which is simulation of like a human brain's neuron, and the process of learning is called a deep learning. Okay, the algorithm for AI is ANN, and the process of learning is called deep learning. Okay, this whole thing comes under data science, and data science is the application of scientific algorithms on the data, the complex algorithms, and this is how the AI has been evolved. And ANN is the algorithm which is used in AI. There are similar algorithms like CNN, RNN. Okay, so these are all neural networks, how we can work on a different use cases. So accordingly we will be discussing this in the future sessions. Okay, let's have the basics and basic understanding about deep learning. Okay, what neuron is, what is artificial neuron, okay, and in the first place what deep learning will bring to us. Okay, why to go for deep learning? Because we had machine learning, but we saw the challenges. The one primarily challenge we saw is the rule based algorithm. Machine learning has the rule based algorithms. Okay, anything out of syllabus can't be handled. That's what primarily we have seen. Machine learning is not intuitive. That's the second point we have seen. Okay, for high dimensions data, machine learning won't perform better. Let's say thousands of features are available, right? So that's where we need to have such a dense network built on the artificial neural network built on top of for each of your data. Okay, and deep learning also extracts the right features by itself. Okay, the important features, the weightage, everything is done through the neural network, and that's what the deep learning is meant for. Okay, there are many examples like object detection, image processing, high dimensions data processing. So those are some of the examples which can be used for artificial neural network, which are part of deep learning. Okay, so deep learning brings the revolution. So deep learning is the true digitization can be done through deep learning for artificial intelligence. So that's the transformation. It is like 150 years ago when the Thomas Edison have given us the electricity. Okay, then that time it has transformed the way industries worked. Okay, and 40 years ago when there was a internet invented, so internet has transformed the industries. That's the second revolution in the industries, right? So internet plus mall became a website. Okay, that's how the business is. That's how every industry has transformed. Okay, and the next transformation or the next revolution would be a true digital transformation through AI. Okay, any company plus deep learning is the AI company, right? There is a strategic data acquisition, the new roles, the automation, data warehouse, the big data. So the every step towards a digitization is having a deep learning, and that becomes a AI company, and that's how the digitization or a revolution we can see now. Okay, so that's what deep learning brings to us. Deep learning brings to us the AI capability, the power of AI that helps computers achieve superhuman capabilities. For example, if I want to watch this number plates, okay, if a human can do number of nameplates, number plates for 10 years, a machine can do that in a single hour. Okay, that's the superhuman capabilities a machine can have, right? And that's what AI brings to us. That's what the image recognition or voice recognition or autonomous vehicles or robotics, so this all falls under AI. Okay, so let's have a little understanding about what we have understood why we need AI, what is deep learning, and what is ANN. Let's have a quick look on little bit detailed deep dive on ANN, right? Or we call it a deep learning basics, or we call it a artificial neural network or artificially created neuron, and that is called a perceptron, a single layer perceptron. Okay, on the left hand side, the diagram you see is the neuron. Okay, there are billions of such neurons are there in the human brain. Okay, each of these neurons communicate with each other through electrical and chemical signals. Okay, so neuron have a processing unit in the brain, so that has capability to collect the data from dendrites. It processes and it passes on to the next neuron or the next layer of neurons through axon. Okay, so dendrites is the feed which is used to feed the input to the body of the cell. Okay, and that is nothing but an electrical and chemical signal which is passes through the body to the axon. Okay, there are different layers of neurons. There are, as I said, there are billions of neurons, teeny neurons in the human brain, and human brain is the best learner on the planet Earth, right? So, and the learning mechanism happens through such teeny neurons which is there in the brain, which collects the data from dendrite and processes it, and then it generates the output through the axon. Okay, so neuron alone can't do anything. Okay, it is like ant alone can't do anything, but the group of ants can build a whole town, right? So that's how the single neuron can't do anything, but it is working with billions of neuron forming the dense network and making such decisions, right? There are so many neurons responsible for every activity. Okay, suppose I see something, if I decide to go to a movie, right, the thought process goes is through a various level of decisions and final decision. Okay, and that whole process goes through such a dense neural network in the human brain, and a similar structure we create artificially with the help of a complex models, complex algorithms, and the statistics and the mathematics. Looks like this on the right hand side, where we have a cell. Okay, we will see what this cell has, a body cell has. Okay, it is a weighted sum of all the inputs, and there are some inputs, let's say x0, x1, x2, and x and so on. Okay, so we have so many inputs there. We have a processing unit, that is the weighted sum, and there is the output. Okay, so this brings you a similar structure, and which can be used for prediction or for getting your output, which is desired output for you. Okay, so this is another image I have just copied, which can be seen here with the help of the names given. For example, the body of the cell, it sums all the inputs, and dendrite, it receives the signals from the other neurons, and the axon, which passes on the signal to the connected neural network or the layer of the neurons. Okay, this is the one more biological neurons picture, okay, copied from this source. So here as well, it is more or less the same thing what we have discussed. The cell of the body is called soma, and soma is the processes the information. It is a processing unit or a body of the cell. Okay, you can see a perceptron. Perceptron looks like this. We can see this is the perceptron, which works on the inputs. We have input layer here, and there is a synapse, okay, which is the kind of age or the weights given to each of the input, and there is a neuron, that is the body, which does the sum of weighted sum of all the inputs, and there is a activation function which is getting fired based on some threshold or a condition, and then it gets a y hat. Y hat is your prediction. Okay, so we can have our output y, we can compare y with y hat and understand what is the difference, what is the cost there, and then we will adjust the cost accordingly, and we do back propagate this output or the error, and then we do adjust these weights to ensure that the cost is low or the error is low, minimum. Okay, that's the whole process of artificial neural network, how it works. So we will be looking at these details, okay, maybe in the upcoming sessions, but this is how the whole process works. Okay, the perceptron process, as I said, there are inputs, there are weights, and weighted sum will give you some kind of a output, and that output is passed to something called an activation function. Okay, there are various types of activation functions, like a sigmoid function. Okay, if you recall, we have learned this in the logistic regression. And there is a ReLU function, there is a threshold function, there is a hyperbolic tangent function. So these are some of the commonly used activation functions. Okay, so activation function is used to transform the input to the output based on some condition. Okay, step function is the easiest one to understand, which can be used to transform your input to the output based on that condition. If this condition matches, it will fire the neuron, and there is the output set to 1, otherwise it is set to 0. Okay, that's a simple process we have. Okay, there are rules and the activation function, how it works. There's a sigmoid function, there's a step function, a ReLU function, okay, and the tangent, right, tangent, hyperbolic tangent function. Okay, so we will discuss about the cost function in detail. So this is what I had for the basic overview of neural net deep learning and AI. So definitely in the next session we will be deep diving into the first example of artificial neural network, and we will see how this training process happens. Okay, so yeah, that's all for this session, and see you in the next session with the more details about how we can use neural network for some of the use cases. Thanks for watching.